Hello and welcome in to the example video for lesson 16 for Precalculus 1. So in this lesson, in this example, in this video, we're going to look at different examples of our exponential and log equations. Share the document camera. All right, so first we are going to solve the exponential equation. So the first one we have is 3 to the x minus 1 power is 27. So you could use your logs or your natural logs and punch a bunch of stuff on your calculator, but you don't get a calculator on your test. So how are you going to do this one? Well, 27 is really what? It's 3 to the third power. And on the left side, I have 3 to the x minus 1 power. So the only way these guys can be equal is if these two pieces are equal, if x minus 1 is equal to 3. So therefore, if I add 1 to both sides, I get x equals 4. Do I know if this is right or not? I can check. Plug in into the original. If x is 4, 4 minus 1 is 3. 3 to the third power is 27, so I know that's my right answer. That's the correct answer. What if I have 4 to the 2x minus 1 is equal to 1? Well, again, you could use your logs and use your properties of logs and like, okay, natural log of 1 is equal to what? That's a lot of work that we don't really need to do because I can rewrite 1 as what? 4 to the 0 power. Anything to the 0 power is 1. So therefore, that means 2x minus 1 is equal to 0. The exponents have to be equal, so add 1 to both sides. I get 2x equals 1. Divided by 2 means x equals 1/2. Check it. 2 times half is 1. 1 minus 1 is 0. 4 to the 0 power is 1. Yep, that's it. Now, what if we have something like this? 2 to the x plus 1 is 3. So if this is on a test, and it could potentially be, and it says solve for x, excuse me, and then leave your answer in terms of, let's say, log. So the first thing I have to do is take log, because I have this exponent here. I have to get that down. How am I going to do that? I'm going to use my law of logs. But first, I need to take the log of both sides. So log of 2 to the x plus 1 is equal to log of 3. So now with my log of logs, I can bring the x plus 1 in front. So I get x plus 1 times log of 2 is equal to log of 3. So now get rid of the log of 2 on this side. So divide everything by log of 2. So I get x plus 1 is equal to log of 3 over log of 2. And so to get x by itself, minus 1 from both sides. So x is equal to log of 3 divided by log of 2 minus 1. And again, you don't have access to a calculator, so that's where you have to stop. That's where you would leave your answer when it's telling you leave your answer in terms of log. So that's how you would do that one. If on WebAssign, it says write your answer in terms of log, and then if it says round your answer to 3 decimal places, then of course you need to use your calculator, which is fine on WebAssign. But again, on the test, you won't have access to your calculator. All right. And then the following, solve for x. So we are now going to look at log equations. And one thing I did neglect to mention on the content video is when we are doing log equations, we must check our answers. Reason being is why? Well, because the log function has a restricted domain. X has to be greater. Well, the log portion has to be greater than 0, correct? So if I had, say, for an example, some equation and it said like natural log of X and a bunch of stuff, and I solved this and I said, oh, X equals -3. Well, that's not possible because I can't have natural log of -3 or log of -3 or log base 2 of -3. So therefore, -3 is not a viable solution in this case. So that is why we always have to check our answers. And I'm telling you this now, on the exam, you're going to get problems where you're going to get X is equal to two different possible answers, and one of those answers is not going to work. And if you don't check your answers, you're going to tell me, oh, George, X equals 1 and X equals 4. No, it doesn't, because 1 doesn't work. And you failed to check your answer, and now you're losing points on that problem because you didn't know what you were doing or you didn't fully know what you were doing. So I don't know if on your note sheet you want to write in big highlighted letters, check your answers, something, so that you do it. So let's look at our first one. We have 3 minus log of 8 minus x is equal to 2. So first thing, I'm going to subtract 3 from both sides. So I get negative log of x minus 8 is equal to -1. Divide everything by -1 to make this positive. So I have log of 8 minus x is equal to +1. And now I have what type of problem? I have log on one side, a number on the other, so I have to do what? The basic log property. Well, what number is here? Well, we don't see it, but it's what? It's the 10. So I bring this over to here to get rid of the log function. So I have 8 minus x is equal to 10 to the first, which is just 10. So then I subtract 8. So I get negative x is equal to 2. Divide by -1. X might be -2. Because what? I have to check my answer. So can x be negative? Yes, x could be negative. It just can't be negative if I plug it into the original and it causes me a domain less than 0. So if I plug this back into the original, here, 8 minus -2 is like 8 plus 2, which is 10, which is fine because it's greater than 0. So then, yes, I'm saying that x is equal to -2 is my answer. All right, second problem. Natural log of 4x plus 1 is 0. So we have a couple things we could do. We could say that we can look at our log, natural log properties, and natural log of what equals 0. Or this is basically what? This is like log base e. So if I do e on both sides, e to the natural log of something is just that something piece. They kind of cancel each other out. And anything to the 0 power is 1. So subtract 1, I get 4x is equal to 0. Divide by 4, x might be 0. Let me plug it back in. 4 times 0 is 0, plus 1 is 1. That's positive. That's fine. So therefore, I'm pretty sure that x is 0 is my answer. What if I have log base 2 of x squared minus 5x minus 28 is 3. So again, I only have log on one side, so the only thing I can do is my basic log property, bring this over as my base. So that gets rid of the log function. So I have x squared minus 5x minus 28 is 2 to the third power, which is 8. So subtract 8 from both sides. I get x squared minus 5x minus 36 is equal to 0. Now I can factor. So I can get negative 9, positive 4. So by zero property rule, x minus 9 is 0, x plus 4 is 0, x equals 9, x might be 9, x might be negative 4. Let's check them. If I plug in 9, I get 81 minus 45 minus 28, which is positive, so that one's fine. If I plug in negative 4, I get positive 16 plus 20, which is 36, minus 28 is also positive. So in this case, both answers are acceptable. X equals 9, x equals negative 4. And then our last example, I have log of x plus 2 plus log of x minus 4 is equal to log of 5x. So I have these two pieces separated. I need to use my law of logs to combine them. So this guy really becomes what? Log, and because it's addition, I multiply. X plus 2 times x minus 4 equals log of 5x. So now, if the left side equals the right side, that's only possible if this piece is equal to that piece, right? So I could subtract log of 5x from both sides, and then I could do my law of logs and combine it into one term. And then I could do my basic log property to get rid of the log functions, but I don't need to do any of that. As long as I have a log on both sides, I can just set these pieces equal to each other. X plus 2 times x minus 4 is 5x. But now I have to FOIL this and I need to combine everything and then factor again. So I get what? X squared minus 2x minus 8 is equal to 5x. So subtract 5x from both sides. I get x squared minus 7x minus 8 is equal to 0. And now go ahead and factor. So I get x minus 8, x plus 1. So x minus 8 is 0, x plus 1 is 0. So x might be positive 8, x might be negative 1 if I check it back in the original. So check x equals 8. If I come back to the original, 8 plus 2 is 10. That's bigger than 0. That's fine. 8 minus 4 is 4. That's bigger than 0. That's fine. 5 times 8 is 40. That's bigger than 0. So that's fine. So x equals 8 definitely works. How about negative 1? Well, negative 1 plus 2 is 1. That's positive. That's fine. Negative 1 minus 4 is negative 5. That's a problem. I can't have log of a negative value. Therefore, negative 1 is not a solution. So the only solution to this problem is 8. X equals 8. That's it. So that does it. You guys made it. It's our last lesson. It's our last examples for the lesson. So good luck on the mastery set. See you in class. And we'll see you in pre-calculus 2, hopefully.